Welcome back to The Explainer, everyone. I am absolutely thrilled to have you 8th grade students joining us today. So I want you to imagine for a second that science is just a massive, continuously growing, infinitely complex puzzle. For centuries, we've been trying to put this puzzle together to understand how our universe actually works. But here is the secret. You literally cannot complete a puzzle if all the pieces are exactly the same shape and color. Science is shaped by diverse voices from all sorts of backgrounds, cultures, and time periods. It's really a shared human effort. And today, we are going to explore exactly why every single unique puzzle piece is absolutely essential to seeing the big picture. All right, here is our roadmap for today. If you've got homework questions, and I know you do, keep your ears open so you know what to look out for. We'll start with the power of unique gifts, move on to why different perspectives matter, then we'll check out some diverse heroes of STEM, and finally wrap up with education meets morality.
Okay, let's dive into this with Section 1, the power of unique gifts. When we talk about science, it is crucial to understand that true scientific ability isn't limited by gender, race, nationality, or the neighborhood you grew up in. It's fueled by curiosity and your unique perspective. The source material anchors this whole idea with a verse from 1 Corinthians 12:4. There are different kinds of gifts, but the same Spirit distributes them. Think about what that means for a moment. It means everyone has a unique superpower, right? A totally distinct gift to contribute. In the realm of STEM, science, technology, engineering, and math, this suggests your specific way of thinking is a unique gift meant to be shared. Science is not the property of one single culture. It is a beautifully diverse, shared human effort where all these unique gifts come together.
Section 2, why different perspectives matter.
So, we've established the what, that everyone has a unique gift. But how does a scientist's specific background actually change the science they do? Well, our culture and life experiences literally dictate the questions we ask and the methods we use to find the answers. This comparison brilliantly illustrates the point. Let's say a researcher grows up in a rural farming community. They are intimately familiar with the challenges of crop cycles, soil health, and weather patterns. Naturally, they're going to ask questions and focus their research in agriculture. Conversely, a researcher who grows up in a coastal region has experienced the tides, marine life, and coastal erosion firsthand. Their environment shapes their scientific focus, right toward the oceans. If we only had scientists from the coast, who would solve our agricultural problems? No one. We absolutely need both. And frankly, we don't just need both, we need every perspective possible, because the world is facing some incredibly complex global challenges. When diverse thinkers work together, they bring completely different problem-solving styles to the table. This variety is exactly what leads to the creative breakthroughs we desperately need. Think about massive issues like climate change, disease prevention, and space exploration. You just cannot solve problems of this magnitude with only one way of thinking. You need a whole chorus of different minds, collaborating and challenging each other to find richer solutions and better ideas.
Let's move to and see how this builds. Section 3, diverse heroes of STEM.
Let's see how this plays out in the real world with 3 historical case studies. You 8th graders are definitely going to want to take notes on this table for your homework. These are pioneers whose diverse backgrounds weren't just a footnote in their biographies. Their unique perspectives were their true advantage and the key to their massive innovations. We've got Katherine Johnson, a NASA mathematician who calculated Apollo 11 trajectories. Dr. Chien-Shiung Wu, an experimental physicist who proved the parity law is not conserved. And George Washington Carver, an agricultural scientist who revolutionized farming sustainability. Let's look closer at each of their extraordinary gifts.
First up is Katherine Johnson. She was a brilliant African-American mathematician working at NASA during a time when both her race and her gender presented massive societal barriers. But her mathematical gift was undeniable. She calculated the exact flight trajectories for early space missions, including the historic Apollo 11 mission to the moon. Imagine that for a second. Before we had the powerful computers we rely on today, human lives were literally trusting her precise math to travel safely through space and return home. Her work was absolutely critical for keeping astronauts safe, and by bringing her unique brilliance to NASA, she influenced the entirety of space exploration and inspired future generations.
Next, we have Dr. Chien-Shiung Wu, a Chinese-American experimental physicist. Now, in the world of physics, there was a long-held belief about how subatomic particles behaved, known as the conservation of parity. It was accepted as absolute fact, but Dr. Wu, she designed incredibly complex and precise experiments focusing on weak nuclear interactions that proved this widely accepted law was actually wrong. Her persistence, skill, and sheer brilliance completely reshaped our understanding of the laws of physics, rightfully earning her the legendary nickname, the First Lady of Physics.
Finally, we look at George Washington Carver, an African-American agricultural scientist. Down in the American South, years of growing only cotton had severely depleted the soil, leaving farmers struggling. But Carver understood the science of the earth. He knew that planting crops like peanuts and sweet potatoes would put vital nutrients back into the soil, restoring its health. But he didn't stop there. To make sure farmers could actually make a living off these new crops, he developed hundreds of new, practical uses for peanuts and sweet potatoes, single-handedly expanding agricultural markets. He used his unique perspective to create sustainable farming methods that healed the land and the local economy.
Section 4, Education Meets Morality.
We've talked a lot about the historical facts today, but let me ask you directly, why does representation in science matter for you? Wake up and think about this for a second, because it ties right into your homework. Honoring the contributions of people like Katherine Johnson, Dr. Wu, and George Washington Carver proves something vital. It shows you that no matter what your background is, no matter your race, your gender, or where you come from, you have a place in the scientific community. You have a unique gift, and you too can innovate and change the world.
So the crucial point is, what do we do with this incredible potential in education? The source material, the heroesmartacademy Godly Learner series, argues that education must be intertwined with biblical morality. The text illustrates that education without morality ultimately hurts, comparing brilliance without a moral compass to a ship without a rudder. Honestly, what is the point of being incredibly smart, of being highly educated, if that knowledge is just used to continue making bad choices that hurt yourself or others? Alternatively, the source points out that spiritual mindfulness leads to true peace of mind.
The source curriculum concludes by pointing to Romans 8:6-7, which promises peace of mind to everyone who keeps their mind spiritual. It suggests that as you engage with the sciences and uncover the mysteries of the universe, you should anchor your discoveries in a mindful, peaceful life. Because true scientific brilliance isn't just about discovering new facts, it's about using those discoveries to bring healing, progress, and peace to our shared world. So as you look at your own unique gifts today, ask yourself, how will you use your piece of the puzzle to build a better, more peaceful tomorrow? Keep learning, stay curious, and I'll catch you in the next explainer.